This is an applied problem for quadratic functions. It's a football problem. Maybe hit pause and read through it. All right. You can't see the very bottom. Let me scroll to it just for a moment. On the bottom, we need to graph it. So I'm actually not going to do it down there. I'm going to do it over here on, I don't know, I'll do it bottom right or something. And we need to work through part A first. It asks for the maximum height of this football and how far it travels at that point. So before we do anything, I want to point out that this 2 right here changes things in terms of this ball. So let me scroll up a little bit. So I have a tiny bit more room, but yet can still read some of the problem. So on part D, we're going to graph this thing, and you start by making quadrant 1. And anytime you throw something, kick something, launch something, it's going to make a parabola. But the question is, do I start from the origin? Do I start higher? Where do I start? And that 2 up there in the function is the y-intercept. Because if I plug in 0 for x, like if it travels 0 feet, that's the starting point. So on your graph, I'd make a dash and call it 2. For applied problems, we're not as precise because we don't want to count. Like some of these numbers are going to be pretty big. So that's our starting point, and we get a parabola that looks something like that. And part A says what is the max height and how far is the ball at that point and how high is it. So in other words, it's asking for the vertex. I wish they would just come out with it and say, what is the vertex? So we can use this formula to start doing it because it's in standard form. We know up here, let me get rid of that circled 2. We know A is negative 0.01. We know B is 118. And C is 2. So we'll use that on part A and maybe on some later parts. We plug in, we have negative 118 over 2 times negative 0.01. Type that in, and we get 59. So right here, remember this is our x-axis, that's 59. That's the answer to the second part of part A. We still need to know how high. So I'm going to plug 59 into the function and type that in. Please show your work whenever you work this. That way, if you have a little typo, I will give you credit. I'll know you meant well. And we get 36.81. So this is the max height. So there's one answer, first question. And here's our distance. So we can label that. This is 3681. All right, let's keep going. So a defensive player is 6 feet from the kicking spot. So see where the 2 is and the dash right here? That's where the kicker is. So there's someone right here at 6 feet from the kicker. And part B is asking, how high does this person, this defender, need to jump to block the punt? So I come over here, they make it sound so complicated, and all we have to do is plug in 6. So let's type that in. and we see it is 8, oops, that looks ugly, 8.72 feet. So instead of a question mark there, let's write 8.72 feet. It's not to scale, sorry about that, but hopefully you get the right idea. All right, lastly, if the ball is not blocked, how far will it go? Where that arrow is, right here, that is the x-intercept. What is that number? We could factor, I don't know how to factor that though, so let's do quadratic formula. So here's our formula, negative b plus or minus b squared minus 4ac all over 2a. Maybe pause it, practice plugging all that in, and let's see if we get the same answer. So you should get two answers. You should get 119.5 and negative 1.5. And hopefully you realize negative 1.5 is behind the kicker. It's over here. That doesn't exist. So cross that out. 119 feet. Let's throw some feet on there. Doesn't want to write. That says feet right there. Sorry, that looks ugly. But this should be 119.5. All right. I hope that made sense. Please practice typing that quadratic formula in and getting 119.5. And I will see you in class.